In this question, we've been told that a pebble is catapulted vertically upwards from a platform which is 1 meter above the ground. It's catapulted upwards with a speed of 6 meters per second. We've been asked to find the greatest height above the ground reached by the pebble. Let's start with a quick diagram. I'm always going to draw that platform to let us know it was 1 meter off the ground to begin with. Here's the pebble, and here's the flight path that it's going to take. Since we're looking for the greatest height above the ground, we're only interested in part of this journey. We're interested in the journey from its projection up until its highest point here. And there's something specific and particular that we always know about this top part of the journey. I've chosen up as the positive direction. The particle is about to stop going up and start coming down. Its velocity is changing from positive to negative. Its velocity for a split second is 0. We're going to use that fact to try and solve this question. So let's go ahead and collect our SUVAT variables, and from there we'll fill in the information that we know. We are looking for the displacement, but we don't know it. The initial velocity is 6, final velocity is 0, and the acceleration due to gravity is negative 9.8. And once again, we don't know the time. Okay, so which formula can we use? That uses S, U, V, and A. That's going to be V squared equals U squared plus 2AS. We'll substitute the values in, and we'll rearrange to solve for S. We know that the displacement from the point of projection to its highest point is 1.84 meters. That's the answer we get from the SUVAT, but it is not the final answer to the question. The question has asked us to find the height above the ground. So we need to include the 1 meter of the platform. This particle has a displacement of 1.84, and it initially was 1 meter above the ground. So altogether, 2.84 meters above the ground. In part B, we're asked to find the time taken to reach this height. So we're still talking about the same journey from projection to its greatest height, so I can make use of all of the same SUVAT variables. But this time around, we're looking for t, we're looking for time. So let's think which SUVAT formula we can use. V equals U plus AT. Substituting what we know, 0 equals 6 minus 9.8t, and a little bit of rearranging gets us t equals 0.612. It takes this particle 0.612 seconds to reach its greatest height, to start to change direction, to go as high as it's possibly going to go.